Now, once again, as per our tradition, we will begin this session and this inaugural ceremony with the university song, and I request everyone to please rise once again. Thank you, everyone. Now, before moving further, we would first take blessings of Ma Saraswati. I cordially invite all the dignitaries on the dais to please join for lamp lighting, symbolizing the dispelling of darkness and the victory of knowledge over ignorance.
Sir.
Now, I may request Professor Ashutosh Biswal, Sir, Dean, Faculty of Education and Psychology, To felicitate and welcome our Honorable Vice Chancellor, Sir, Professor Bharat M. Malaviya.
Soul and movement. Sir.
Now I request Dr. Satyajeet Chaudhari Sir, Head Textile Engineering Department, to welcome our Chief Guest Dr. Ajay Ranga Sir, Chairman and MD Science School. I request Dr. Suryanarayana Sir. To welcome our guest of honor, Shri Udas Newkar Sir. Lastly, I request Dr. Patel Sir, Head Textile Engineering Department, and Dr. Lata Pandey Ma'am, Coordinator, to please welcome Professor Ashutosh Biswal Sir.
Bharat.
Today, we are deeply honored to have among us our highly respectable Vice Chancellor, Sir, Professor Bharat M. Malaviya, Sir, a true symbol of wisdom and excellence. So, with great humility and respect, I now invite Sir to please step forward for his address and enlighten us by his words. Please, Sir.
Chief guest, Dr. Ajay Ranga ji, Shri Udas Newkar ji, and Ashutosh Biswal sir, and faculty members here, and students, as well as faculty members who are attending the FGP course. In fact, sustainability is a today very important buzzword, I can say, but is it a buzzword? No, because it is required. Today's need of ours, and everywhere it's across all the sectors sustainability is required. You take any industry, and the kind of pace of growth we have, question always comes to our mind whether it is sustainable. And we are utilizing our nature's resources in such a speed that probably next generation will not have those resources. So how they will survive? That we have to think, and we have to develop technologies by which we can use abundantly available materials or develop recyclable technologies or recycle, rethink, reuse, use extended use. So many things you can think of when you are thinking about sustainability. In fact, in education sector also you need to think about sustainability. Current education practices, whether it will continue, no. We need to change a lot in sustainability aspects with respect to education sector also. It can be textile, today's topic I say, nano composites, textile, everywhere sustainability is required. Fortunately, textile sector has developed many new technologies so that today's clothes are having longer life. Today's color are retaining for longer periods. So anything which you increase the life is also sustainability. Then in electronics as well as battery, everywhere you have to think about new research wherein you can reuse the used material and get all the resources which otherwise we are getting through mining. Many elements are now endangered. What I want to say that these elements may not be available through natural resources via mining. So you need to think of technologies called as urban mining. So many things you can think of. Sustainability is need of our. Lots of research requires in the area of sustainability, and from that perspective, I feel such type of conferences are required, and one conference is not enough. You need to have many more because this is a diverse area. In fact, I kept my talk in today's conference, but due to some reason, I will give it on some or the other day. I will touch all these subjects in my talk, and with this short speech, I would like to take your leave. Thank you very much.
Thank you, sir. It was our immense pleasure, and we look forward to listen to your talk. Now, I am delighted to call upon Sri Ulhasankar sir to please come forward and address the gathering with your enlightening words. Please, sir.
I think the group has already heard me for an hour and a half. So they must be saying, oh no, not again. Okay, but it's an honor to be here to inaugurate the event. A little change in timing. But I think as we discussed in the morning, a couple of points that we sort of to add on to what we discussed is on the circularity, that's initiatives that are happening right now in the field of textiles. So currently textiles, the end of life, as we briefly discussed in the morning, is not very well defined. So the initiatives that are taking place right now worldwide, first of all, is to, as they say, recycle, reuse, all the R's are there. But the biggest R is refused, as one of the students said. And we don't use that R because the refuse is not an option. So we have to look at others. So currently there are downcycling, upcycling, these are happening. So downcycling is where they would use that material for panel material or for, in one case I was in Berlin, they had the denim jeans shredded to make the inner panels of the Mercedes-Benz car. So in a way it was a reuse of this material, but on the other hand I thought that it's making a biodegradable material not biodegradable. So is that a right way? Upcycling is where a lot of designers have come forward to take material from old clothes and remake it into something which sells at a much higher price. So this is there. But the third one, which would be called as fully circular, is where let's say a t-shirt becomes a t-shirt again. Yeah, it was not switched on, huh? Okay, but I guess you could hear it loud enough. So where a t-shirt becomes a t-shirt again. So to this context, there was a very interesting machine that was kept in Hong Kong Polytechnic for a while, where you could actually take your t-shirt, leave it on one side. There was a device that would first cut it, shred it, make it back into a fiber. It happened all in front of you in about 5 to 6 hours. It would spin a yarn, and on the other side it would knit, and then a t-shirt came out on the other side. This was more like a demo machine just to show how circularity can happen from one end to the other end. But at the end of the day, every single waste that we have today will need to become a resource for tomorrow. That would be truly circular. Now, amongst the initiatives taking place, cellulose has been done by some companies. But there's the Stockholm University. This was incidentally a university invention that became a business. So, cellulose is a fiber which was where they've already crossed 1,000 metric tons. So, it's no longer even pilot stage or something. It's in the commercial application. And a lot of studies are going on about chemical recycling. where both cellulose as well as polyester and acrylic and others, you can depolymerize and then repolymerize. So circularity will be a need of the hour again tomorrow, and all ideas on circular is something that we can look at. When Dr. Surya invited me to this, when I heard the composition, I said this is really the need of the hour, because no one branch of science today can cater to the needs. It will have to be a very complex mix of, I think, every single branch of science and technology that is available in order to come to solutions for tomorrow's problems. So I think with these few words, I would just say this inaugural event is really nice, and I hope you have a splendid next 12-13 days that are there. 45 lectures, it's a lot. And at the end of the day, there is an exam. And he said there is an exam for the speaker as well, so how many marks you're going to give me? So thank you very much and have an enjoyable day.
Thank you, sir, for your valuable insights to the current issue. We are deeply privileged to have with us today our chief guest, Dr. Ajay Ranta, sir, Chairman MMT Group, who is a pioneer in nanotechnology. I now request sir to please come forward and grace the stage with his golden words. Please.
So, good afternoon, everybody. Very happy to be here with you this afternoon, and thank you for accommodating this afternoon session for me to come and be with you. My friend Ullas has already spoken to you on sustainability and a lot of innovation in textile, I am assuming. So, he is a very knowledgeable person. I think I see that a lot of the participants are the faculty members and also maybe the future faculty members. So we are all in the process of educating people. If I have to give you a clue of how do you sensitize your class, your students about the concept of sustainability. So the way I explain people is, we are all visitors to this planet Earth. None of us have come here permanently, agreed? So that point needs to be made. Everybody has a return ticket, nobody knows when. Right? Okay. Now the question is, when you look at sustainability as a concept and you are looking at the resources which we are consuming as a society, as a generation, as a journey through our life cycle during the visit, you are in 21st century. You ask your students to imagine that when the visitors of year 3000 will come and they want to look back at the history of this earth and particularly 21st century, how are you going to be perceived by them? So we want our students to get sensitized that how they are going to be perceived by the visitors of year 3000. And my understanding is, and I'm sure all of you will agree, that we will go into the history of earth as one of the most selfish grandfathers, grandmothers who ever visited planet Earth. This is exactly going to be how the history is going to write about us. That we did not care about the future visitors. We are consuming limiting resources at a pace which is unprecedented. Take simple example like cement. We build a home today, it lasts for 75 years, and we break it down. Now, is cement forever? When the deposits of limestones are gone, finished. You can't make cement. So, the step number one which you are going to sensitize the student is that the first step of sustainability is to innovate extension of life cycle, of limiting resources. So start studying particularly in material science, in textile, in composite science, in polymers, doesn't make any difference. Steel, metal, it doesn't make any difference. Anything which we use which has a limiting sort of a concern, can you extend its life? So let's say a home. Can you build a house and protect it for 500 years? Why 75? 1,000 years. That's the technology which you need to pursue. Can you build the structure which will go through the earthquakes, through the deterioration of sun, rain and all these? That's what the thought process will have to be in terms of addressing sustainability. So, now whether this is applicable to any resource, it doesn't make any difference. So first step is extension of life cycle. Second definitely is the second level where you can substitute that with unlimited resources. That is step number 2. And step number 3 is this full circularity. Very difficult to achieve. But you will have to go in 3 steps. Being a person from industry who wants to make money every day, there is a hard fact of reality. Paisa, paisa or paisa. If you do not sensitize that any technology intervention, any scientific intervention which you bring which has no commercial relevance is a waste of effort on your part. So every project must write a preamble saying that what is the commercial relevance, maybe today, maybe in near future or maybe in the far future. At least some level of commerce need to be put in every scientific discovery or every scientific effort which we are likely to do. If you don't do that, either you are too ahead of the curve and it has no meaning and people will not be interested. There are so many projects I have seen sitting on the shelf and it's a waste of effort of everybody. So make sure that money is always part of the scientific pursuit which you are doing. Now coming back to sort of my own subject, polymer science and maybe composites, I can speak on many subjects because I have dealt with textile chemicals, I have dealt with road construction chemicals, I have dealt with construction, the new generation of mineral paints which are supposed to last for 100 years also, and I am dealing with biofarming technology where a complete elimination of chemicals is now possible. So all these are basically technologies which address sustainability. To share my particular background, in 1997 when I set up Zydex, I was among the maybe the first ones in India who wrote Innovation for Sustainability in 1997. Because when I heard the Finnish Prime Minister putting this concept in the UN in 1994, I was very impressed with his thought process. And I said, this man is talking sense. This is the key goal of 21st century. If anybody needs to build business, anybody needs to make a good dent on the way science will progress, industry will progress, this is the thought process. And since then, we have pursued that with the principle. Every project which we do in our company, we ask this question that are we really addressing the 3 steps which I outlined? Is it going to be commercially feasible? And the most important thing is, I particularly look at it, is it at the bottom of the pyramid? See, being in nano area, being in polymer science, surface science and all that, I had the luxury of application of my understanding and knowledge in many areas. I could have gone in electronics, I could have gone in many sophisticated so-called bio areas. I chose not to do it. Because I said, if I am committed to sustainability, where is the maximum impact? The maximum impact is where the bulk of the commerce is. तो हमने रोटी कपड़ा मकान सड़क इसको पकड़ा, and everybody in the beginning क्या कर रहे हैं? This is not an exciting area to work in. There is nothing, basically there is no glamour here. But I said, look, these are the areas where maximum resource consumption is happening, which is to be worried about. And every time you define a project, every time you ask a student to do a master's or a PhD, or you yourself are doing something, ask what is the total impact this research project is going to have. जैसे हम लोग एक टैम बोलते हैं ना, टोटल एड्रेसेबल मार्केट, तो टोटल अवेलेबल रिसोर्सेज को आप कैसे एड्रेस कर रहे हो? थिंक अबाउट दैट. दिस मस्ट बी रिटन, दिस मस्ट बी असेस्ड, अदरवाइज यू विल नॉट नो what is the importance of your project. Even if you go and represent in terms of DST, you go, they will look at you saying that I don't understand the relevance of this project. So make sure that you build the context of what is the impact of that material. Few examples I will give you how innovations are done for sustainability. It's very interesting. One day I was just walking in the morning, and I do a lot of my sort of thinking during that time. So I was working on biofarming as a project, innovating in that area. So I realized that many times we see that the plants are growing in the rocks. The roots are not going into the soil, and the plant grows. And I started scratching my head. How the hell this plant is getting water? How is it managing to grow without the root zone going into the soil? And I kept on thinking about it. And then I realized, what are the places where we see this? And then I realized that you only see this near the rivers, on the mountains, and near the sea, or near the sort of water bodies. I said, what is unique there? Then I realized that the relative humidity in the night, see how thinking is coming. I'm just trying to share with you an innovation process in terms of sustainability. I said the relative humidity is high. So what is happening? So every night the condensation, the dew formation in this zone is much higher. And these leaves must be starting to act like roots. They are absorbing because there are cuticles, there are stomatas which are open in that leaf, and the water must be getting absorbed. I said, okay, that's a revelation. Now what do I do? As a polymer scientist, my first attempt saying that, can I take this principle and bring it in every farm? So what do? I create a new biodegradable polymer technology which can be sprayed, formed a very micro level coating, which is capable of absorbing this dew water, because all these leaves have waxy layer on them. So many times you see the dew water coming in and rolling and going down. It's not actually absorbed. So the moment you have a hydrophilic layer, a water absorbing layer, you are essentially now have the capacity to harvest that dew water. I said, okay, that makes sense. Let's pursue this. And we pursued it. Now, something interesting happened. See how now nature and sometimes unknown things help you, and this is what we call as luck. When we started doing actual practical trials, we realized that not only the water stress is gone, the plant is actually growing better, faster. And then I am scratching my head. What the hell is happening? This can't be only water. Then I realized that the new water is coming from air. Air has CO2, though 428 ppm today. But that CO2 is highly water soluble. Then I looked at the table. So CO2 was 0.2% soluble, 2000 ppm. And the liquid form I am getting now. So not only I harvested the water, I harvested CO2, which is the key raw material for photosynthesis, in a liquid form. You can imagine a 22.4 liter condensing into 44, gram cc. And suddenly that made a lot of sense. I said, okay, dew water not only gives me water but also CO2. And the sun, Bhagavan to aata hi hai roz hamare yahan. Photosynthesis accelerated. So this is called the luck factor. And in science, let me comment on luck factor. One of the research director with whom I work in United States, who is the author of more than 100 patents. So one day I used to like to join him for lunch. So I asked him, Dr. Christensen, explain me your fascination about lucky chemist and a smart chemist. So he said, Ajay, I like smart chemist, but I love lucky chemist. So this is the difference. Smart is always acceptable, likable, but loving, lucky. So you have to be lucky also sometimes. So nariyal porte jao, jabhi bhi project karte ho. But jokes apart, all I am trying to say is sometimes when you think scientifically, many things which you do not anticipate actually happen. And it's a post-understanding that you say, oh, I thought about that, actually you didn't think about that. So this is something to talk about, sort of an innovation cycle, what typically we go through when we talk about sustainability. Now naturally you have used the natural phenomena, you have used the biodegradability, you use the polymer technology, you use the emulsifiers to do all that, whatever the technological package there is, and you take the utmost care. But if you can increase the photosynthesis efficiency in the farming, you have created a value. And this is where this thing comes in. And now you compare that how much water you can save. Water is a precious resource. So this is how you will assess that in sustainability, how much water is impacted. Let me give you an interesting statistics on water only. The President, our Mr. Jaiswal, shared this with us in Delhi, who is basically heading the irrigation, micro-irrigation companies in the country, for drips and sprinkler and all that. China, so-called our competitor, neighbor, benchmark, today produces same or more amount of food at 1/4 the water consumption. Look at how disastrous the situation is. And water tables are falling in India. That's a sustainability problem. See how you have to think. I mean, you can see sustainability in every aspect. It's not that it has to be only materials. So, unless you consume less water, produce. Now, look at a very simple aspect. Again, how to think. I'm just sharing with you how to think and how to go forward. If you use less water and produce food, if the plant is stressed, the first thing you will realize that the plant will have more resistance power to survive. It will try to grow its roots more. Its absorption capacity will increase. And the critical minerals, like calcium, magnesium, and so many others, the zinc and the borates and all kinds of things, they will not get diluted. That means your nutrient density of flavors, antioxidants, your vitamins, your, whatever we will call as the everything will be far more denser per unit weight you are producing. Why it is important? Well, many of us are older in this room. Our calorie consumption is going down. But I want the same amount of nutrients. How do I get that? So objective of sustainable agriculture is not only a safe food, organic food, maintenance of fertile lands, restoration of water table, but also providing the public with nutritionally dense food per unit calorie. That's to be measurement. So this is where the science comes in. Because what is important? You cannot consume more than a certain amount of calories. So this is where the thing comes. That's the definition. Per unit calorie, can my flavor, can my aroma, can my taste, can my experience. When I talk about experience, that's what the money is getting paid for today. Go into the market and see. People spend enormous amount of money for experience today. So anybody who will address these things is going to be commercially successful in taking the sustainable technology into practice. So when we look at sustainability, don't look at sustainability only as a part of academics or innovation or culture, but look at it, can it be actually taken to practice? So this is where I would come from as a practicing person, as an industry person. I don't know how much time do we have? Done?
We have.
We have. You have time? Okay. You're not getting bored, no? Okay. So, let me share with you some of the futuristic things where I feel India should focus on in the area of sustainability. So if you look at the largest area of sustainability is our infrastructure. The rate at which we depreciate is the first criteria you must write in any sustainability project. That means limiting resources and the rate of depreciation. If you cannot assess at what rate you are depreciating, you will not be able to define life cycle. Today in India, we are building infrastructure which is deteriorating at an average of 4 to 5% per year. Sometimes 2%, but typically 4 to 5%. You need to reverse that, bring it down to less than 1%. You must build everything which has a life cycle of 100 years, 200 years. This is your challenge. If you really look at where to identify opportunities in India, we are going to spend trillions of dollars in India on creating infrastructure to live well, to call as a developed country. So look at infrastructure and the related issues when it comes to sustainability. Be it a design, be it a material science, be it the quality of construction, be it quality of inspection, all are part of sustainability. You should not think that only materials is sustainability. Anything which produces extension of life is part of sustainability campaign. So infrastructure is one area where I would suggest have a deep look at it. Definitely textiles is one area which you must look at it. I myself have worked on growing cotton now organically at the same cost, same yield, improving the land, reducing the water consumption, and making sure that all chemical pesticides are not required. And this is actually commercial. Now only we think we need to do is adopt in the Indian textile industry to make it as a part. We are now making a big effort in Government of India, we are working with to make Kasturi cotton synonymous with organic cotton. So organic cotton is a big area of concern. Organic pulp, even today, growing forestry without chemical fertilizers is an important area. So can we do that? Things like right from jute to banana fiber to everything, this country is plentiful. You have sun, you have water, you have Himalayan wall, amazing sort of contribution towards enjoying what we call as production of biomass. Look at that biomass and see where the sustainability can come from as material science and as you can go towards the circularity. So textile definitely has a lot of things. Polyester being a thermoplastic can be recycled right from PET to the clothes to this. Decoloring, basically removing all these toxins from the whatever we are doing to embellish our products, and all that needs to be looked at. So the more and more we can simplify our designs, our coloring agents, our embellishments, I think we can recycle them more easily. And definitely the technology will evolve in that direction. The most important thing in textile to me is extension of life. This is one of the key parameters of sustainability. Can you eliminate biological degradation? That's the most important degradative mechanism which you find. Can you look at UV degradation? Because your clothes are getting exposed to UV. Heat is not a problem. But UV and biology are the two factors which you will have to take into account. And can you slow down these processes? Can you slow down the kinetics? This is sustainability. If you look at, let's say, engineering fibers, there are many fibers, right from carbon fibers to so many graphite fibers to so many of them, metal fibers, everything. Can you utilize them in the composite area? And how do you make them longer lasting, better functionalized, better compatibility, better reactivity? How do you characterize the surfaces? There are so many things. And that's where a lot of sustainability will come from. So textile is another big area in terms of application for India, because we have 140 crore people to clothe, and maybe we can export. So at least 250 crore लोग तो है ही हमारे पास जिसको कपड़े पहनाने हैं हमको. And I'll tell you, this is sustainable business. Why? As long as the baby is born naked, you are in business. Okay? So हमेशा ये पूछना कि भाई धंधा होएगा कि नहीं आगे 50 साल के बाद, बराबर है ना? So you are in the business to innovate for textile. The third area, again, which is a big area, is agriculture. We spoke about it. You are people of material science, even in textiles. There is a lot of textile application which can happen in agro, in terms of sort of creating artificial conditions where the productivity can shoot up. You can control the diffusion rates, you can control the incidence of sort of light intensity, you can protect them, you can reduce this, abiotic stresses, and all kinds of things can happen. So you can also look at that. One of the areas which I feel is a big thing is automobiles. As we, as a country, will populate ourselves with respect to the transportation capability. We talk about urban transport, we talk about railways, we talk about aeroplanes, but the cars are going to remain the future major transportation element, the way we live currently, and I think the way we will live in the future. Can every part of the car become recyclable easily? Can you actually break down a transportation solution and address sustainability through the composites? Now composites, you have a big problem. You are thermoset and you cannot get out of that. But look at a silk worm. Look at the spider. He's creating a web and it is supposed to be 7 times stronger than the steel in terms of by weight. Now there is a clue. So thinking that only composites can deliver strength is not necessary. It's your capability of designing a system to produce that level of crystallinity, that level of structure, that level of integration is what matters. आपका जो चेन पैकिंग है वो कैसा हो रहा है? That's the key. And all this is happening at room temperature. The fun part is all this is happening at room temperature. Today, microbiology is developed to the point, you look at mRNA, our famous company in Boston, Moderna, they are able to engineer viruses in the lab. Today you can engineer microbes synthetically to produce whatever you want. Why can't a sustainability project go into designing microbes to produce these quality of fibers which can give you a thermoplastic composite as strong as the thermostat? See how you will have to define. You know the problem, you have a scientific mind, you have the understanding, but you will have to look at the clues around and say that, okay, can I define this? This is how the thinking has to happen. This is how the whole approach needs to be taught. This is where the PhDs will have to come out. You know. So that's a big area. The composites, particularly with respect to household furniture, automobiles, and there are so many applications. But making thermoplastic as a way of the future can be fantastic. Can we avoid putting the color inside the system? Like today, polyester, you are putting the dispersed dye in the fiber. Can we just do it on the surface? Can we live with that? Will it not make it easy? Will it not be number of grams of dye per square meter be less? This is sustainability. See how small things, if you observe and start looking at it, you will realize that sustainability is not a word, it's a religion. It's a practice which you can live with. You can find it in anywhere, everywhere, and you have to just apply your mind. Does that make sense? Yes. Okay, I think I have spoken enough. So, again, thank you very much for sharing time with me and asking me to come and share some of the sort of my view on this subject. Again, thank you very much. Bye-bye.
Thank you, sir, for that inspiring talk. Your expertise adds great value to our understanding of sustainability. So as we draw this wonderful inaugural ceremony to a close, it gives me immense pleasure to say that today has been a milestone filled with insightful words and inspiring energy. At last, I kindly request Dr. Satyajeet Chaudhari, sir, to please conclude the ceremony with a vote of thanks.
Thank you. And namaste to all. So on behalf of our organizing committee, we are going to conduct this 2-week refresher course. So I thank first of all to our Honorable Vice Chancellor, Professor Bhalchandra Pandey sir, from his very busy schedule. Earlier he was going to stay for 3 hours over here, but due to instead his rescheduled programs, he gave half an hour to us. So I am very much thankful to Pandey sir for his excellent his encouragement to us. Then our sincere thanks to our Dr. Ajay Raka sir, who is the chief guest today in today's inaugural function, for his enlightening address on the fundamentals of sustainability. Sir, your insightful approach on thinking sustainability in a real and practical sense will certainly guide we all participants throughout the next 2 weeks. Thank you, sir. I extend my deep appreciation to our chief guest of honor, Shri Ullas Nimgarji. So within a week, he gave his time to us from Thane, especially, and his journey we just heard in his lecture that how it was. So thank you so much, sir. And today's lecture was also very, very enlightening that in a limited sources, how to manage, what are the challenges we have. A special thank to our Dean sir. Today he is also busy and not in the Baroda, so he couldn't attend the function, but he has sent his blessings to us. So I am also thankful to Honorable Dean sir, Professor Ganesh Patel. Our heartfelt gratitude to Professor Ashutosh Biswal sir, Director UGC MMTTP MSU Center, and also he is a Dean, Faculty of Education and Psychology. Sir, because of you only this refresher course became possible. So from the whole organizing committee, I am thankful to you, sir. Thank you so much. I am also thankful to the coordination committee, coordinators committee, and for their dedication, planning. And yesterday also, at 12:30 night, they were awakened by us only at the hotel. So tireless efforts are there by the coordination committee. Though I can't take the name, there are 12 teachers who are coordinating, plus 2 students volunteer who are continuously recording the sessions. And this session, sir, we are going to upload on YouTube channel of this FT MMTTP. So in future also you can refer these lectures. So and finally the participants, thank you so much. Because of you only this event became possible. So I am very much thankful to you. Keep your enthusiasm and commitment and be present in each session, because after every session you have to feel the feedback. And last, we bow our heads to Almighty for granting us this strength, because when it was started, we were very disturbed that how we will call the 45 experts for the lecture, this lecture, but he gave the strength, clarity of the work and opportunity. Also, we found that yes, it is possible. So because of his strength only, so I am thankful to Almighty. And finally, whose names I couldn't take, teaching, non-teaching staff who has helped to make this successful, clean environment. You can see because of our PUs, technical staff who is handling this technical articles. So I am thankful to all. So thank you so much.
One comment I would like to make. Just as a part of sustainability, I am looking at this. Is it really required in this slide? Think about it. Point to be noted for the organization. For the comment, but
I now request everyone to please stand for national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना विकसित रंगा, तव शुभ नामे जागे, तव शुभ आशीष मागे, गाहे तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता।